So we said to solve this polynomial, we should factor it by grouping because there are 4 terms, right? So we said what was common in the first 2, and we said x squared and got x minus 8. We said what's common in the second 2, and we got 1, and that was 11x plus 20, and then we knew we were in trouble. Why did we know we were in trouble? They don't match. They ought to be the same if we're going to factor by grouping. So instead of quitting and crying, we decided we had to have another strategy, right? Now, Alexia wanted to do synthetic division. Okay? Alexia, I just want to know how you would get the number on the outside. That's not wrong. Okay? How do you decide how to get the numbers on the outside? Do we just guess? Even if I set it equal to 0, that's still not going to help me. Because if I set it equal to 0, I'm still trying to solve. You guys are jumping ahead of me, which I'm very proud of, because you're already wanting to do what we're going to do later. I'm just trying to get us to that point. I'm not mad at all. That's awesome. Okay? I'm saying to you, if we're going to do synthetic division on this, which we are, okay, how do we get the number that goes on the outside? Can I give you the answer? You don't know yet. Guess what we're learning today? Yes, that's what we're learning today. Okay? So, because here's the deal, guys. If we do synthetic division, what are we looking for specifically if we do synthetic division when we're trying to find a factor? A remainder of, yes, say it, 0. Okay? A remainder of 0 will say that it is a factor of this polynomial, right? So, think of all the numbers we could possibly choose. How many of them are there? Yeah, infinity, right? I would like if we had less than infinity numbers to choose from. Would you also like that? Yes? Okay. Can I show you how to find those numbers then? It has a specific name. Okay? It's called the rational root theorem. The rational root theorem says if we can take all the factors of the constant and divide it by the factors of the leading coefficient, that will give us all of the possible factors to try. Right now, how many possibles do we have to try? Infinity, right? So if we use the rational root theorem, that's going to help us make it a smaller number of numbers that are possible factors. Okay? I need to make sure your vocabulary is up with mine. Is that fair? The factors of the constant. What the heck does that mean? Constant. 20. It's the number without an x, right? Factors of the leading coefficient. If you literally use your brain for approximately 0.4 seconds, you can figure out what a leading coefficient is, can't you? Leading means first. Coefficient means number in front of the variable. Exactly. Okay? So in this problem, what's our leading coefficient? 1. It's right here. Okay? Now, this is true if this is in standard form, which means the exponents are in decreasing order. Right? Remember that? Remember us talking about that already? Okay. So, tell me please, what are all the factors of our constant? What are the factors of 20? 1 and 20. 2 and 10. 4 and 5. Now, I need to argue with you a little bit. Because all the factors of 20 are yes, 1 and 20. But what about negative 1 and negative 20? Doesn't that also work? Yes or no? What about yes, 2 and 10 work, but what about negative 2 and negative 10? Doesn't that work also? So instead of just writing the factors like this, we need to write the factors like this, so that we take into account all the positives and the negatives possibilities. Now, is that true every time, or if it's only a positive number? What if it was negative 20? Would I still have to write the positives and the negatives? What do you think? How would I get negative 20? I'd have to go either positive 1 and negative 20 or negative 1 and positive 20, right? So I still need the negatives, don't I? All right? And then I need to divide that by all the factors of the leading coefficient. This is going to be a hard one. What are the factors of 1? Oh, okay. Do I still have to have plus or minus? Yeah, just in case. Okay. So what do I get if I divide everything in the numerator by 1? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Now, some people are still like, man, that's still 12 possibilities. 1 and negative 1, 2 and negative 2, 4 and negative 4, and so on, right? So you're mad about having 12 to try instead of infinity? Ugh. Are you going to be okay? If you're going to cry because 12 is too many, I do have tissues. Okay? So now what should we do? Lexia, what would you like to do now? Synthetic division, right? Okay? But I'm only using these numbers instead of whatever random number I can think of. Those are the numbers I have to try. When I do my synthetic division, what am I looking for? A zero as a remainder of 0, right? Okay. What do you want to try first? So you guys are going to be the jump arounders. I have 2 possibilities. Either you jump around or you start at 1. Okay? So you want to start at what? 1? 1, negative 8, 11, and 20. Some people's brain needs to go in order. I'm okay with that. I'm going to stop. Why am I going to stop? I'm going to stop because I'm a smart person. You would stop because you are a smart person. No matter what this is, when I multiply it by 1, I mean, I can kind of tell what it is, right? I know in my head that it's going to be 4, right? Okay. When I multiply it by 1, is that going to be negative 20? And that's what I need this to be, don't I? I know that 1 is not going to work. I don't need to take the time to completely finish the problem if I know 1 is not going to work. Are you freaking out? Good. Now what? Negative 1. Excellent. Good choice. 1, negative 8, 11, and 20. 1, negative 1, negative 9, 9, 20, negative 20. Yes! What do you mean, why did I change the sign? Because I multiplied it by negative 1. Okay. Now, I need to know if you want to do this problem the hard way or the easy way. Both ways you can get the right answer. So that's not one of those times where I'm going to teach you the hard way because it works every time, but the easy way doesn't. It works every time, both ways. What do you want? Easy way. Okay, can I show you what the hard way is? Continue doing synthetic division just exactly like we did with every number until I get all the answers I need. Is that hard? No, I just did 2 of them and it was super easy. Okay? Can I take a timeout for just a second? Yes? Okay, thank you. Before we go on, I need to know how many answers I need. I don't want to have to do 12 entire synthetic division problems when I found all the answers. I just don't know how many answers I need, so I just do them all. That's silly. Okay? Let's talk about the fundamental theorem of algebra. Does that seem relatively important to you? If something is called the fundamental theorem of algebra? Yes? Okay, I hope so. I'm trying to read it to you, if I could find it real fast. Okay, I cannot find it real fast, so let me abbreviate, okay? Basically, in the very basic form, the fundamental theorem of algebra says whatever your highest exponent is, that's how many answers you should get. Okay? So how many answers am I looking for? 3. And if I'm going to do the synthetic division thing the whole time, if I'm going to do it that way, once I get 3 of them, that equals 0 for my remainder, I'm done. Right? But you said you wanted to do it the easy way, right? Yes? So the easy way says I stop right here because I found one of my functions, or excuse me, one of my factors. Can I translate this back into an equation, or excuse me, an expression? Because that's my remainder, so that's my constant, and that's my x term, and that's my x squared term. So this says x squared minus 9x plus 20. Oh gosh, I know how to factor that, don't I? We just spent 3 days on figuring out how to factor this, didn't we? What is it? Try again. Has to multiply to be 20 and add to be negative 9. Negative 4 and negative 5. Guys, how many answers do I have now? 1, 2, 3. Right? How many am I supposed to have? Okay. So now we have to figure out what the directions are of the problem that we're given. Because the directions will depend on what we do next. Okay? If my directions say factor completely, is that spelled right? It looks totally wrong. Do you ever do that? You write a word and it looks wrong and then it's probably right, but okay, whatever. We're going to pretend that's how you spell completely. What are my factors? Well, aren't these 2 of them right here? X minus 4 and x minus 5. How many am I supposed to have? 3, so what's my third one? Doesn't it have something to do with this? If this is a negative 1, why did I write x plus 1? That's exactly right. Okay? When we first started synthetic division, we were given the factor, and to get the number that goes in front of the synthetic division, we set it to 0 to put it here. Now, if I'm going backwards, I have to think the same way. Right? Does that make sense? So if the directions say factor completely, that is your answer, and you are done. Okay? If it says solve or find all the real solutions, isn't that kind of solving though, right? Or find all real solutions. It's because at the very beginning, the problem looked like this. If it's just an expression, all we can really do is factor it, right? But if it's an equation that's equal to 0, I need to figure out what x is that makes this equation equal to 0. And I do that by solving. But the cool part about it is I can go from my factors to my solution so fast. Because if that's that initial problem factored, doesn't it still equal 0 like the original problem did? Guys, if I've got a bunch of things multiplied together, oh, did it just go yellow? Blue? Awesome. I don't know why. It's freaking out again. Look, I'm so cold, my hands are blue. Huh. Okay. Let me see if I can use red, see if that'll help. That's super weird. If I have things multiplied together and it equals 0, what has to be true about at least one of these? It has to equal 0, doesn't it? So I'm multiplying things and it equals 0. The only way I can do that is by multiplying something by 0 to get 0, right? Well, which one of these is it? I don't know either. Okay? So we're going to just take the chance that they all are 0. X minus 4 is 0. X minus 5 is 0. And x plus 1 is 0. So I just take each of these small little equations on their own one by one and solve them. X equals 4. X equals 5. X equals negative 1. These are my solutions. These are my factors. Okay? These are factors. These are solutions. Just for the record, these are also called zeros. Like there's literally mathematicians who have fought about this, like had arguments about this and written papers in favor of one versus the other. And I'm like, you have too much time on your hands if you're arguing about what these are called. Okay? Because here's the deal. These are called zeros if we're graphing this to see where the graph crosses the x-axis. But the thing about it is where the graph crosses the x-axis are also the solutions to the equation. So if you want to call them solutions or zeros, okay. These are factors. You can tell that because they're numbers being multiplied together to get the original equation. But these are zeros or solutions. Okay? Any questions about that? Now, one thing I'll caution you on, and this only affects a couple of the problems on the homework, so I'm not going to do a whole example for it because it's the same the same steps that we just did. But what if it's that? It doesn't matter. This is a 3. How do I start this problem? I start with the rational root theorem. I take all the factors of the constant and divide it by the factors of the leading coefficient, right? Well, what are all the factors of the constant? 1, 2, 3, 4, 6, and 12, right? Divided by the factors of the leading coefficient. What are the factors of 2? 1 and 2. So this time I have a little bit of an extra step here, don't I? What's everything in the numerator divided by 1? The same thing, everything in the numerator. So I'm just going to write it down. Plus or minus 1, 2, 3, 4, 6, and 12. But what is everything in the numerator divided by 2? What's 1 divided by 2? 1/2. What's 2 divided by 2? Literally, does anyone know what 2 divided by 2 is? Okay, 1. But I already have it on my list. Do I have to write it again? No. What's 3 divided by 2? 3/2. What's 4 divided by 2? 2. I already have it on my list. What about 6 divided by 2? 3. I already have it on my list. What about 12 divided by 2? 6. Already on my list. So this is where I start. Now, earlier people were freaking out. They were like, I don't want to have to try fractions. Guys, who chooses where you start on your synthetic division? You do. Do you have to start with the fractions if you don't want to? Then don't. Start with 1 and do all the possible ones. If it doesn't give you a 0, do all these first. Chances are one of these is going to be a 0 and you don't even have to mess with these. But if I ask you to list all the possible solutions, these had better be there or they're not all there. Does that make sense? Any questions on this? We're not going to finish this problem because I literally just made it up out of my head, so it probably doesn't have nice, pretty solutions. Okay? But we start by doing the rational root theorem. Knowing in our head that whatever the highest exponent is, how many answers we're looking for, right? Okay? I find all my factors of my constant divided by factors of the leading coefficient, and I write those out. Those are the numbers that are going to go in the front of the synthetic division. I'm going to do the synthetic division until I get a 0 as my remainder. Sometimes you'll get lucky and it'll happen on the first one. Sometimes you're going to have to do 3 or 4 before one pops up. Don't get frustrated, just do it. Okay? Once I have one that has a 0 as my remainder, convert this answer back into a polynomial and factor that. Those are your two of your factors. Here's the third one. If it wants it factored, you go here. If it wants the solutions, set each one of those factors equal to 0 and solve them. Does that make sense?